Well, hello once again. This is KP the Math G. This time in our study, we're going to lay off doing one of the, like a 2006 problem or a 2007 or 2008 problem. Lay off the test for another couple of videos here because I do want to introduce this integration technique. It's a trigonometric substitution. It carries with it three forms. You have to memorize so much to be able to do these forms. I'm sure this is probably in the BC part of the AP calculus. I don't believe that this would apply to a regular AB class. Okay, but hey, if you're interested, you can look at this and kind of get some things a little bit ahead, right? If you're in a regular calculus class, I don't know if you've had this or not, but if you have, this is good review, and if you have not, here's something you need to look at. Okay, let's take a look. It does carry with it three forms. You do have to, remember this identity: sine squared plus cosine squared theta is equal to 1. And there are three, as actually more than that, but mainly you want to get cosine squared is equal to 1 minus sine squared. Secant squared is equal to 1 plus tangent squared. Tangent squared is secant squared minus 1. And you have to kind of remember that. So that kind of helps to, be able to do the problems by this trigonometric substitution method. Also, it's going to take on these three forms. I have a triangle here. Well, actually, I just kind of memorize this. The A is a number, okay, like 3 or 4. The U is like X, okay. The square root of A squared minus U squared, where sine of theta is U over A. Now remember, U over A is opposite over the hypotenuse. Opposite of theta over the hypotenuse. And then the X value is the square root of A squared minus U squared. That's where this comes from right here. Okay, and we're going to be substituting in the X, and so that's why I want to show you these X values. Alright, the second one, if you see a plus sign, it's automatically tangent. Okay, that's U over A. Tangent is opposite over the adjacent. So opposite over adjacent. Opposite of theta over the adjacent. And then of course, if you do the Pythagorean formula on that, that's going to be A squared plus U squared is whatever. Okay, C squared, whatever. But C squared is equal to the square root of A squared, or C is equal to the square root of A squared plus U squared. Okay, the idea behind these are going to always be square roots, and the idea behind this method is to remove the square root. That's what the idea is. Okay, and then the third one, okay, I've got, see here, look here, I did sine. Okay, of course I could have done sine squared is 1 minus cosine squared, but anyway, secant squared, 1 plus tangent. Tangent squared is secant squared minus 1. Okay, and so we're dealing with sine, secant, and tangent. Sine squared, secant squared, tangent squared. Okay, and actually, yeah, cosine squared. That's what we'll get into. You'll see when we start doing an example, and I may just have time for just one of them. Alright, so the third one is U squared. That is the hypotenuse over the adjacent, the hypotenuse over the adjacent. I was looking at the wrong one. Hypotenuse adjacent. And then this will be the square root of u squared minus a squared. That's, well, I know it's y, but sometimes we refer to that as x also. Okay? Alright, so those are the three triangles that you need to become familiar with. What helps me to understand the triangles is just understand u over a opposite over hypotenuse. That's going to be sine. And then, of course, your hypotenuse squared minus your x squared or whatever, okay, square root of that. Tangent, again, opposite over adjacent. Always set it up that way. Alright, that's what helps me. And then when you do the Pythagorean formula, you get this right here, okay? And the same thing with secant. This is hypotenuse over adjacent. Set it up this way, like that. And then, of course, we do want to solve for x. We're going to substitute this or this or this into the equation. That's what we're looking at, okay? Now, we're going to have to refer back and forth to this pretty frequently. So, I do have a problem. Another thing too, when you are doing these problems, you need to make sure that you do understand that you go back over integrating sine, cosine, tangent, cotangent, secant, cosecant, secant squared, let's see, cosecant, and secant tangent, and cosecant cotangent, and so on. And so those are things that we need to keep in mind as well. Okay, let me get my notes over here. Sorry about that. Let's put them over here. Okay, we are going to remember, just remember, if you can set this up opposite over adjacent, you can get this right here. You don't have to worry about memorizing it. You don't have to really commit it to memory. If you can just, opposite over, set up your triangle and then find this one, okay? And then, of course, you're going to use the triangle to find your final answer, okay? Alright, so let's do one right here. Alright, I don't know if it takes up a lot of paper, so I don't know how much space I'm going to have left up here. So let's go ahead and try one. We're going to do it. It starts off like this. We're going to integrate dx over the square root, or actually let me just go ahead and write it down this way so I can save. I might go ahead. They write it like this: x squared plus 1 to the 3/2. And by the way, we can rewrite that as dx over, now this means the root, okay, that's the index, or index, alright, and then this up here is the power, alright, or the exponent, okay, so I can rewrite that x squared plus 1 raised, I'm sorry, I should have the square root, that's the square root there, and then I can cube that, okay, like that. Now look, I'm going to rewrite the patterns again, and you decide which one. Now here's the three forms. One is a squared minus u squared. I don't have a a squared minus u squared. Matter of fact, if I wanted to, I could make this 1 plus x squared. 1 plus x squared is the same as x squared plus 1. But just so we see the idea, that's a minus, so that's out of the question. And there's another one I could, okay, so in other words, just turn it around. U squared minus a squared is definitely not it. This is sine, isn't it? Okay, this is secant, so this one has to be tangent, doesn't it? Alright, so this one is a squared plus u squared. Okay, that's in that form here. A squared, a is 1, alright, and u is x. Okay, so here's the pattern. We have tangent of theta being equal to u over a. So in this case we're saying tangent of theta. Alright, we got to decide that. Look right here. This is the u. U is really x and the a is 1. Alright, so u, or x over 1 then, which is just x, but we're going to leave it like that right there. So if we set up the triangle on the side here, I'm going to try to make it big enough to see but yet small enough to do the rest of the problem. Alright, this is opposite over adjacent. Okay, so opposite is x and then 1. And then if I were to do the Pythagorean formula on this, this would be, well, 1 squared plus x squared is, well, let's make it something c squared maybe. Alright, so then 1 is, okay, so that is like that. So if I take the square root of c squared, that's the square root of 1 plus x squared, and that's what I have here right there. Alright, so that's it. That is c, is 1 plus x squared. Alright, so that would be the square root of 1 plus x squared. So we need to fill in this part up here. We need to know this is, we can't just put 1 and x randomly. We can't put them in. You got to put opposite over adjacent. You got to understand that this refers to, this is the pattern of this one over here, and that refers to tangent. Okay, alright, so that is what we're dealing with right here. Okay, alright, so now that we have our triangle set up, let's go ahead and do a little bit of work here. Okay, so and in this case probably I'm probably, okay, so okay, so also I need to think about this as well. So I know that tangent theta is equal to x. Tangent theta is equal to x. I almost forgot that part of it. Then the derivative of tangent, okay, is secant squared theta d theta. So we got to know the derivative of tangent is secant squared, okay, and this side is dx. All right. So we have a little substitution to make. In place of dx, we're putting secant square theta, secant square theta d theta. That's in place of dx right there. Okay, bear with me, okay, hang with me. Alright, now we have something over here That is cubed, isn't it? Alright, so we're cubing this, and we're going to put in what we've got here. That is, so let's see, this would be in place of x. Okay, let me think just a little bit. 1 plus, okay, I'm getting sidetracked here just a little bit. In place of x, I'm putting tangent. So I've got it written backwards. So 1 plus, alright, in place of x, x is equal to tangent. Alright, and it happens to be squared, so square it like that. And that's basically what we're looking at right here. Okay, so in place, it's been a long time since I've done this problem again. I've done it and then I got it in my mind, and then I've got to think about what I'm doing here. So 1, I'm following the pattern. 1 plus what? Well, x happens to be tangent. That's what I'm doing. And since it's squared here, I'm going to square it here. 1 plus tangent squared happens to be secant. Okay, so this is going to be secant squared theta d theta. This is the square root of, and it's cubed, of course. You got to remember that that is cubed. Alright, this is 1 plus tangent theta. If we turn that over on the other side, that's going to be secant theta. Go back over. 1 plus secant theta is 1 plus tangent square theta. So secant square theta is 1 plus tangent square theta. Okay. Alright, so that's what you're trying to do. That's what we want right there. Secant square theta. Now we know what the square root of a squared is. It's just a. Alright. Alright, I am talking about the principal root right there. Okay, so that's it right there. Okay, so let's see. We have the square root of secant square theta d theta over, now the square root of secant squared is just, and the square root of secant squared is just secant, so secant theta, and that's raised to the third, isn't it? Raised to the third power. I could put the 3 right down here like this. Okay, move that over and put the 3, sandwich that 3 in there like that. Okay, like that. Now I can start looking at this. Alright, so let's see. This is going to be, there's 3 of these. It's like a cubed, a squared. We know that there's 2 of these gone and 2 of these are gone. So this is actually 1 over a, isn't it? Alright, so what we have here, alright, so we're integrating. Both of these are gone, and 2 of these are gone, so we're left with 1 over secant theta d theta. But that's really nice because I know that 1 over secant is cosine. Well, we got to remember that. Wow, so much to memorize. Now I know the antiderivative of cosine is sine theta plus c. Gotta remember to put the plus c here. But now sine theta is equal to the opposite over the hypotenuse. So let's go back over this. Here's sine. I can't leave it as sine. I want to leave it in terms of x. That's what we started with. Okay, so here's opposite right here. Here's the hypotenuse right there. So this is equal to opposite x over the square root of 1 plus x squared. Alright, now plus c. Alright, you eventually want to get back to that x right there. Okay, that is a whole lot to swallow, isn't it, at one time. Alright, so very quickly I'm going to try my best to make sure that we understand this. We could leave this like this. We don't have to bring this up like before. So the first thing we need to do here was establish which pattern, which one of these we're using. Obviously, if there's a plus sign, we are going to use tangent. Remember, this is sine, this is sine theta, secant theta, tangent theta. Okay, right there. Alright. So tangent is, in this case, x. Always take the u to be, the x is going to be the u, and the a is going to be the number. So since it's u over a, x over 1, which is just x, okay. Alright, we had to find what this was. We already should have known, if we do the Pythagorean theorem, this is just square root of 1 plus x squared. That's what we've got up here in the first place, right here, right? Okay. Now, eventually what we need to do, also, we still need to take the derivative of tangent, which is secant squared, and tangent theta, the derivative of tangent theta, secant squared theta d theta. I put that right up here where dx is. And in place of x, I did have to put down tangent. We did have tangent theta is equal to x, but that was squared here, so 1 plus tangent squared is secant squared. The square root of secant squared is just secant, but then when we knock out these exponents here, we're down to 1 over secant, which is cosine, sine theta plus c now. You got to remember that the antiderivative of cosine is sine theta. And then go back, because we don't want to leave it in terms of theta. We've got to change it back in terms of x. So that's why we do it. That's why we substitute, so we can come back to this. And it turned out to be opposite over the hypotenuse. Had this been cosine, we would have had 1 over 1 plus square root of 1 plus x squared. But it's going to usually be sine or secant or tangent, usually. Okay, it's going to come out like that. Okay, that's what we have here, and that's what we've got. So we'll do another one whenever we get a chance to do one. I don't know about tomorrow, but probably Monday we'll do another example, maybe even a third part. Okay, and then we'll get back to our free response question. KP the Math G, make sure that you fellas, ladies and gentlemen, that if you have not subscribed, please do so. That's I say you don't have to, but it does help if you do. Do that, and please also, if you have a comment you'd like to make, please make a comment. If you have a like, if you liked it, hit that like. It just puts it, you already see me smiling, don't you? Okay, well anyway, it does make me smile a little bit. Anyway, KP the Math G signing off. You ladies and gentlemen have a great day. Let me do that again. There we go.